Hello class and professor. So this week we're going to be going through the buoyant force and floating lab. My name's Nathan Sexton, and the materials we're going to need for this is a half stick of molding clay, popsicle stick, 15 washers. You need some table salt, paper towels, clean up, water, 250 milliliter beaker, 100 meter graduated cylinder, and a measuring spoon. Alright, so going through, doing experiment 1, it's all about items feeling weightless in the water, and this phenomenon is due to the buoyant force that acts on a solid submerged in the liquids. So we're going to take this along with the saltwater solution and compare it to plain water to show how that affects the density, because salt water is naturally a higher density and has a higher buoyant force that it can exert in comparison to normal tap water. Alright, so going through, we went through, and we're going to take here we're going to go through with our cylinder here, pour 150 milliliters into this 250 milliliter beaker right here, and then we come through here, we got our salt washers over here, and then we have a ball of clay. So we go through, roll through, it'll be placed in here. As you can see, sinks right to the bottom due to lack of buoyancy. The force of gravity and its mass dragging it towards the bottom. And then after this, we remove it from the beaker. We need to make a clay boat. So I was struggling with this at first. It took me about half an hour, and we'll see if it still floats. I already completed my experiment, and I'll go through and detail out some of the information in the table. But I end up having to use another piece of clay. But what you want to do is make a really flat, wide bottom, and then fold up the edges a little bit so the water doesn't come through. Give it as much surface area as possible to go through. The only problem with this is if this clay was a little drier, it might be a little bit more pliable. I'd say it would have helped if I left it out for a day in the heat maybe, because it's just floppy and it doesn't really like to go through and stay correctly. So you're going to place your boat in the beaker and go through. Let's see if this will still float. It was floating earlier. Alright, sank straight to the bottom. I'll have to try with another piece of clay later, due to this one not holding up as I want. But flat, wide base, give it more surface area. It'll take away some of the mass and move everything around and go from there. When it came to it, I was able to get 3 washers in my boat initially before I made the video, in the plain water before everything floated to the bottom. And when I did the saltwater mixture, I was able to get 5 washers. This was due to the higher density caused by the salt in the mixture. So after you remove the boat and the washers, mix 5 teaspoons of your salt into your beaker, stir it well. Big container, so I ended up having to use this. Like I said, I completed the experiment a little bit earlier to get my results. And then as far as it goes, we got our answers for all of this. More information will be included in my lab workbook for not only how Archimedes' principle corresponds to this as well, but how the buoyant force is affected by things such as tension and gravity and everything else really that applies to it. I hope you have a great day. I look forward to you looking through my workbook, and I look forward to all that we can learn about buoyant force. Have a great day.